Dear students, welcome to the Teachers Clubs. Myself, Dr. Tarun Sharma. Today, I will going to teach you about a very important topics of 12th class science subject of physics, electronic device. The last unit of 12th class, it is semiconductor devices topic is there, and in this my lecture I will cover this topic. If you like this video, please like, subscribe, and share our Teachers Club channel. So the electronic devices, if you see in this uh, slides, these are the various small components are there. The capacitors, ICs, transistors. These are the electronic devices, and these electronic devices are made up of the semiconductor materials. So in these slides, we have various semiconductor electronic devices, semiconductor, conductors, and insulators, and energy bands in the conductors. So in your syllabus of this unit, you have conductors, semiconductor and insulators, energy bands in conductors, semiconductor and insulators, intrinsic and extrinsic semiconductors, P-type and N-type, p-n junction semiconductor diode, IV characteristics in forward and reverse bias, application of the junction diode, and diode as a rectifier. So in this lecture, I will cover conductor and semiconductor and what are these conductors, semiconductor and insulators, how the energy bands behaves in conductor and semiconductors, and what are the difference between these three materials, different materials. So conductors are basically those materials or those substances that allow the electricity to flow through them, that is metals, humans, animals, others. So anything which conducts the electricity to pass through it. Like metals like gold, silver, iron, we humans connect to catch the electricity, and other animals also. And semiconductors are those materials whose conductivity values falls between that of a conductor, such as a metallic copper, and an insulator, such as glass. And the examples of the semiconductors are silicon, germanium, gallium arsenide. And then the insulators are the material or substance that resist or don't allow to pass the current through them, are the insulators. They are in general solid in nature, and the insulator they use do not allow to pass heat through them. And these are the wood, fabric, glass, mica, and quartz. Okay. So conductors are defined as so basically what happens here. So semiconductors are depend upon the property. They can sometimes behave as an insulator also, sometimes they behave as a conductor also. So the semiconductors are very important nowadays, and it is used in the mobile phones, laptops. In the first slide I show you small pieces like a diode, transistors. Okay, and nowadays chips are made with the help of the semiconductors. So all our home appliances like a washing machine, a refrigerator, televisions, and the backbone behind them is the semiconductor materials. So what makes special these semiconductor material and why they have a dual advantage of acting as a conductor as well as insulators? That depend upon the material property and how this bonding between the atoms. So I think now in 12th grade you must know about the Bohr's model. You studied the Bohr's model and how the valence band and conduction bands. So and forward energy gap. So that is the bonding between two atoms. It plays a very important role, and how is the valence band conduction band difference is there. So next we come to it. So first we understand what are the various characteristics of these materials and how this uh, conductors, semiconductor, and insulators behaves. Okay, and what are the definitions? So definition: conductor is a material that allows the flow of charge when applied with a voltage. And the semiconductor is a material whose conductivity lies between conductor and insulators. An insulator is a material that does not allow the flow of current. Okay. So temperature dependence: the resistance of a conductor increases with increase in temperature. The resistance of a semiconductor decreases with increase in temperature, and it acts as insulator at absolute zero. Very important. resistance decrease as the temperatures increase. So it will act as a insulator. Okay. An insulator has a very high resistance, but it still decreases with the temperature. Conductivity, the conductor have very high conductivity, 10 to the power minus 7 ohms per meter. So they have electric density, and they have intermediate conductivity. Semiconductor 10 to the power 7 to 10 to the power 13 range. They can act as insulator and conductor at different conditions. An insulator, they have very low conductivity. So that's why they do not allow to flow the current through them. So depend. So conductivity is the main difference between these three materials. These three different conductor, insulator, and semiconductors. If you have very low conductivity, then not allow the fast current through them. Means very high difference between valence band and conduction band. If you have moderate conductivity, they will depend upon the temperature condition and flow of the current through them. Very high conductivity, they connect electricity through them. Conduction band, valence band difference very less. Conduction. So how the conduction will happen? Due to electrons, due to holes, due to free electrons. So in the conduction in the conductor, due to only the free electron in the metal bonding. Okay. And conduction in the semiconductor is due to the movement of the both electrons and holes, vice versa. So as I think you must understand what are the electrons and holes. Electrons are the free particles, and holes are created when the electron deviates space. There are no free electrons and holes, so there is no conduction in the insulator. So band gap. So band gap is also very important. If band gap is very high, then the valence band and conduction band is so high so that we need a very high amount of energy to break the band and to little conductions, bring the valence band to conduction band. Then conductivity starts. So if there is a we can say no or low energy band gap between the conduction and valence band of a conductor, it does not need extra energy for the conduction state. The band gap of the semiconductor is greater than the conductor but smaller than the insulator. So 1 electron volt. So their electron need a little energy for the conduction state. Okay. And band gap of the insulator is very huge, 5 electron volt, which need an enormous amount of energy. Okay, for the flow of the electrons. And resistivity is very low, 10 to the power minus 5 ohm, as we discussed there. And normal semiconductor 10 to the power minus 5 to ohm per meter to 10 to the power ohm per meter, and very high in case of insulators. And now energy bands is semiconductors, semiconductor insulators. So what are energy bands basically? So if you remember in solids, there are bands of energy levels are formed due to the intermixing of atoms in a solid. These set of energy levels are known as the energy bands. In solid, the energy level of outmost orbit electrons are affected by the neighboring atoms. Okay, so what happens? They will bring to close together and depend upon the energy band gap. They have isolated charge and then brought close to each other. And the electron in the outermost orbit experience an attractive force from the nearest or neighboring atomic nucleus. The electrons in the same orbit have a different energy levels. The grouping of these different energy level is known as the energy band. And these energy band leads to the formation of the band, and these bands helps to conduct the pass the movement of the electrons and holes from one band to another band. So here we have three types of basically band: valence band, conduction band, and forward energy band. So valence band is the electrons in the outermost orbit of an atom, now called the valence electron band. And these valence electron band have highest energy, and this band may be partially or completely filled. Okay, and conduction band, it is a band of electrons that are responsible for the conduction of current in the conductor, and all the electrons in the conduction band are free. So they are free, so that is a conduction band or conductors. Forward energy gap. So this is a gap between conduction band and valence band on the energy level diagram. The width of the forward energy gap indicates the band of electrons of its atom. The less the forward energy gap, the less tightly the valence band to electrons and vice versa. Okay. So what happens here? Energy band in the insulators. semiconductor and conductor. So you see in this diagram here, the insulator first one, and you see the insulators vary a very huge energy band gap. For is known as a forward energy gap. Valence band, they have the previous slide as we see, all the electrons are there, and they have conduction band is there. Okay, and the valence band is semiconductor band gap is less because the forward energy gap is less, and they will easily go from movement of electrons and holes. The electrons will move here, they create a holes. Both sides will conduct, vice versa. And conductor, there is a no free valence band and conduction band. So there is a no movement of the electricity. So in the insulators, the valence band is fully occupied with the electrons due to the covalent bond. The electrons can be not moved because they are locked up in insulators. Okay, between the atoms. So to achieve the conductivity, sorry, in the conductor, the valence band has very less probability gap and they move very freely. So very high conductivity conductor. To achieve the conductivity, electrons from the valence band have to move into the conduction band. This prevents the band gap which lies in the between the valence band and the conduction band. And further, in semiconductor there is a band gap, but compared to the insulator, it is so small that even at a room temperature, electrons from the valence band can be lifted into the conduction band. Okay, so these electrons can move freely and act as a charge carrier. So these charge carrier electrons have created holes in valence band behind and which can be filled by other electrons in the valence band. So one gets widening holes in the valence band which can be viewed as a positive charge carrier. Okay, and in the conductors, the valence band is either not fully occupied with electrons or not fully filled with the holes overlapped with the empty conduction band. In conductors, there is no band gap. Okay, so that is the main reason. So you should understand what is the difference between in these slides. What are the semiconductors? What are the insulators and conductors? So I repeat again, semiconductors are those materials whose conductivity lies between the uh, between the conductors and the insulators. Okay, so low the huge the band gap at the forward energy gap, so lesser the conductivity. So the insulator they have very high band gap, forward energy gap, and the conduction is very less. Okay, so I think with the end of this slide now you're able to understand what are the semiconductors and what are this advantage of the semiconductors, and nowadays what are the applications that is most important why you are studying about the semiconductor. Okay, so in the next slide I will explain you about the how the semiconductor is used as a rectifier and what are the voltage characteristics and how this semiconductor will be used for the voltage and current characteristics. Thank you.